Hello and welcome back. In this video, we're going to take another look at Pallet from Spectro Cloud. In case you haven't seen the previous videos, Pallet is a tool that allows us to get production-grade Kubernetes clusters using very strong composition methods via packs, allowing you to tweak every aspect of your Kubernetes cluster. We've already seen the power of this model by using the Spectro Cloud Web Console. But as you move towards production, you may choose to use something that can be version controlled and reviewed by everyone on your team. Changes can happen via pull request. And of course, we know this as infrastructure as code. One of the key technologies to make that happen used by most organizations around the world is, of course, Terraform. So, in under 15 minutes today, what I want to do is show you how to get the same production-grade, composable, pack-based Kubernetes cluster on your cloud of choice using Pallet and Terraform. Let's go straight over to the console, kick things off, and then we'll take a look at the code. I'll see you in a second. So, here we are in a Terraform project. I'll show you the code in just a minute, but as running Terraform and spinning up an EKS cluster can take a little bit of time, we're going to start with a Terraform apply. Now we could run plan first, but because this is the first time we've done anything with Terraform, running apply is going to present a plan and ask us to confirm. We can see here there's quite a lot going on because we're deploying a full production grade cluster. But at the bottom, we can see we have a kubeconfig, cluster endpoint, cluster ID, cluster name, profile ID, etc. Right? These are all of the outputs from the resources that we're putting together as part of this IAC infrastructure as code project. To make this happen, we have 5 resources also being created. One of them is an EKS cluster, some of them is deployments via packs, etc. So let's just approve this. We'll give this about 35 minutes, which is how long it takes to spin up a new EKS cluster. This is not a Pallet or a Terraform problem. This is very much an Amazon EKS problem. So we'll let that do its thing. And meanwhile, we'll take a look at the code. So the first thing we want to take a look at is providers.tf. This is just a file where we put all of the providers that Terraform needs to be aware of so that when we run Terraform in it, it knows to go and fetch them. So, of course, we have the Spectro Cloud provider, version 20.6. If you're ever unsure how to find a provider for your project, you can just come to Terraform registry, registry.terraform.io, search for Spectro Cloud or whatever you need, and click. It will bring you to this page. You can click on Use Provider, which will actually show you the HCL that you need to copy and paste into your project. You can also click on documentation where you'll have access to all of the resources and data sources, and you can see how to use these with examples throughout. Fantastic resource for working with any Terraform project. So we have our Spectro Cloud, and because we're using AWS, we have our AWS provider, and we also have random and TLS, which are used for some sub-resources throughout this. The random one is specifically used to generate our Grafana password in an infrastructure as code way. If your providers require any config, you can just add your provider block to the bottom. I'm using environment variables to satisfy all of the required API keys and endpoints required for this project. I am hiding them away in my envrc, which I will not be showing you today. When the provider is configured, you then need to start putting together the resources that you need. Now, if you're using Spectro Cloud and you want a cluster, the chances are you're going to come down to here and pick the type of cluster you want. You can, of course, also search. Now, because Pallet supports AKS, AWS, Azure, EKS, GKE, GCP, etc., 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 you pretty much just click on the one that you want. And again, the examples are here to guide you on your way. If we pop open our cluster.tf here, you'll see that I have my EKS cluster, which is using a cluster profile. And we'll take a look at that in just a moment. We then connect our cloud account. Now, because we're using EKS, we have to connect our AWS account. This is available via our AWS account.tf. Now, this is just pulling in our access key and secret key and then using the resource account to connect this together. As you'll see with Pallet and Spectro Cloud, these things really are just simple, which is appreciated in Kubernetes in 2025. Now, for a Kubernetes cluster, we don't need, well, for an EKS cluster, we do not need a control plane. We're using EKS, which means the control plane is going to be managed for us. But we do need to configure one or more machine pools, workload pools for the cluster. So here we have a very simple worker pool where we're using variables to set the number of nodes, the min and max, and the instance type, as well as the root disk size that we are happy to have. You can also set your update strategy, scan policy, and any timeouts. All of this is very well documented by scrolling to the bottom of the cluster page or searching for scan policy like so. You can click on this and it shows you we can set the configuration scan, conformance scan, and any sort of penetration testing scan like so. If we're curious about the update strategy, again, we can search for that and see that we can set rolling update scale out or rolling update scale in. So let's take a look at that cluster profile, like so. So the cluster profile is where most of the magic happens. Then to put this together, we give it a name. Again, we're using Terraform variables for pretty much everything throughout this entire project. And don't worry about trying to squint at the code. I'll make sure all of this is available on a GitHub repository as well as the resources section below. We say that this is an EKS cloud or cluster, and the type is cluster, because of course with Pallet we have the ability to do cluster profiles and add-on profiles. We then start to layer in the packs, and I've said this a few times in other videos, but the thing I love most about Pallet is the abstractions are right, meaning that the developer experience and the user API for the way that I work with the project just feels ergonomic. And being able to layer these packs together to get what I consider a production cluster is the secret sauce. So here we have some sort of pack called EKSOS. This is our operating system pack. We'll take a look at how we get these values in just a moment. But right now we're saying, hey, we have an operating system. We then have a Kubernetes pack saying, okay, this is how we configure EKS. You can see here we're pulling in just some YAML files from the pack values directory, which again we'll take a look at in just a moment. We then have our CNI. Now, because this is an EKS cluster, of course, we're using the EKS CNI or the VPC native CNI. We then have the CSI, which is just how we hook up storage to our cluster. And again, because it's an EKS cluster, we're using the AWS EBS volumes CSI. Now, it's hard to tell from this what these look like because we're using so much of the data resources. So I think now would be a good time to pull up the data.tf. So this is where we use the data resources in Terraform to query the Spectro Cloud public registry. So when we want to work out which operating system we can use, we can just say, hey, let's look up the Spectro Cloud registry, and I'm looking for Amazon Linux EKS version 1. So of course, if this were to fail, the Terraform plan would fail, meaning we can never deploy an invalid cluster. We're also looking up the Kubernetes EKS version 132. Again, if this fails, we cannot get past the plan stage. This is great for making sure that you never deploy what is essentially an invalid or broken Kubernetes cluster. Now, of course, it's Kubernetes, so it can be broken in 100 other ways, but at least this approach has given us some guarantees. We then have our CNI, where we're looking up the CNI AWS VPC EKS Helm version 119.5, and of course the CSI for AWS EBS. Now, of course, you can look up any packs from the Spectro Cloud public registry. So if you want Cert Manager or KubeCost, you can do that here. And lastly, I've just got my Grafana password where I don't really care what this is. I just want it to be secure. So we're using that Terraform HashiCorp random provider to get a 20 length string with special upper, lowercase, and numeric characters. Perfect. So this is a cluster profile which powers our cluster. And if we're lucky, when we pop back over to the terminal, we should see that our Terraform apply has completed and we have a cluster. Let's check. So that completed in around 26 minutes and we get our Pallet provision production grade EKS cluster with all of the packs that we need. Let's pop over to our browser where we can click on EKS. And we can see our 132 cluster is there. Nice. If we click on that, we can click on compute and we see that we have our worker pool as well with our 2 desired nodes. We can also pop open the Spectro Cloud console UI where we can click on our cluster and see everything is running and healthy. And to be honest, exactly as we need it to be. Now, that is essentially the brand new cluster greenfield project approach. But one of the perks of using infrastructure as code is to be able to version control changes over time. So I feel that we should walk through the process of updating something within our cluster and doing a Terraform apply to see that change rolled out. Okay, so let's make some changes to our cluster. The first thing I'm going to do is pop open variables where we have our minimum number of nodes and our desired nodes. We're going to bump those up to 3. The other thing I want to do is come to our cluster profile where I can increment the version and add a new pack. Here I'm saying I'm going to install cert manager to the cluster. This is going to use our certmanager.yaml files. Which, if we pop open the pack values and open it up here, we can see that this is just a small envelope around your Helm chart values. There's nothing magic going on here, and everything that you're already comfortable and familiar with is completely transferable. This means if we run a Terraform apply, we should see a few things happen. 1, the cluster machine pool, worker pool should change to have 3 nodes, and we should see our cluster profile updated with a new version and a new pack. So let's run a Terraform apply and preview the plan first. And we can see here, if we scroll up, that we want to increase the machine pool from 2 to 3, and we want to add a new pack to our cluster profile as well as rotate the version. This looks good. Let's click yes and let it work its magic. It should take just a few seconds. Voila. So let's head back over to the browser. We'll just give that a refresh. We can see some node action happening here. It seems that our timing is slightly unfortunate and that we're also deleting a node, but that's okay. We do have our add-on deploying. We can see Cert Manager here. It's in the process of deploying. If we click on nodes, we can see that we have 3. I guess we just caught some sort of random scale up or scale down event at the same time. If we click on events, we can see that it's trying to deploy Cert Manager. And if we scroll down, we can actually see that there was a deleted worker node event about 10 minutes ago as well. So that is managing a production EKS cluster on AWS with Pallet and Spectro Cloud. As you can see, well, one of the unique, amazing selling points of Pallet and Spectro Cloud has been able to do some very nice things via their UI, getting a declarative, state-driven, reconciled Kubernetes production cluster. You don't need to throw away all the tools that you're happy and comfortable using already. If you want to use Terraform to have your infrastructure as code in a Git repository tracking everything via pull requests and review, you are more than welcome to do so without losing any of that convenience that Spectro Cloud provides. We can use the data APIs to look up packs within the Spectro Cloud registry or your own registry if you're going down that path. With Spectro Cloud, the choice is yours. Have it your way. I hope you found this video useful. We'll be diving into more approaches to managing production Kubernetes cluster with Pallet and Spectro soon. So we'll see you again in the next video. Have a great day.